interface range fast Ethernet 0/0 and loopback 1. I am going to enable OSPF on these two interface, not on fast Ethernet 1/0. Right here, we are not going to advertise this interface in OSPF fast Ethernet 1/0. I have advertised fast Ethernet 0/0 and loopback 1 into OSPF. Now let me configure R2. On R2 also, first of all, I will configure IP interface fast Ethernet 0/0, say no set, and IP address is 12.1.1.2, 255.255.255.0. Exit interface fast Ethernet 1/0, say no set here, and IP address 23.1.1.2, 255.255.255.0. Exit. Router OSPF 1, router ID 2.2.2, and let me advertise interfaces in OSPF. Interface range fast Ethernet 0/0 and fast Ethernet 1/0. IP OSPF 1 area 0. IP OSPF 1 area 0. Here also on R1 interface range fast Ethernet 0/0 and loopback 1. IP OSPF 1 area 0. Soon OSPF neighborship will come up between router 1 and router 2. Till then, let me configure IP addresses on router 3. Config T, interface fast Ethernet 0/0, say no set, and IP address 23.1.1.3, 255.255.255.0. Exit interface fast Ethernet 1/0, no set, and IP address. See, between router 3 and router 5, I will use 35 network, 35.1.1.3, 255.255.255.0. Done. Interface loopback 1 and IP address on loopback interface is 3.3.3, say 255.255.255.255. Exit. Router OSPF process 1, router ID 3.3.3, and let me advertise interfaces in OSPF. Interface fast Ethernet 0/0 and loopback 1. IP OSPF 1 area 0. IP IP OSPF process 1 area 0. Right. Now let me verify OSPF neighborship. Here we have OSPF neighborship between router 1 and router 2. Between router 2 and router 3 also we have neighborship. Now first of all, you should check connectivity between 1.1.1 and 3.3.3, because you are going to form BGP neighborship between 1.1.1 and 3.3.3. So first requirement is both are reachable with each other. Both should be reachable with each other. So let me check connectivity between router 1 and router 3 through loopback. So I am going to ping 3.3.3 with source 1.1.1. Say ping 3.3.3.3 and source is 1.1.1. So see, ping is working. That means there is connectivity between 1.1.1 and 3.3.3. Now let me configure first IP addresses on router 4 and router 5. After that, I will configure BGP. So on router 4, I have one LAN interface fast Ethernet 1/0, say no set, and IP address is 10.1.1.1, 255.255.255.0. On LAN interface, I have configured 10.1, and on fast Ethernet 0/0, I will configure 14 network. IP address is 14.1.4, 255.255.250. Correct. Then R5 config T, interface fast Ethernet 1/0, say no set, and IP address over here is 50.1.1.1, 255.255.255.0. Exit interface fast Ethernet 0/0, interface fast Ethernet 0/0, say no set, and IP address 35.1.1.5, 255.255.255.0. Done. IP configuration is done. IGP protocol configuration inside service provider is done. Now we are going to configure BGP. So let's start configuration of BGP from router 1. On router 1, router BGP AS number here is 100, and I am going to say your neighbor is 3.3.3, whose remote AS is also 100, and neighbor 3.3.3.3 update source loopback 1. As you know, if you will not define update source loopback 1, then router will send message with source 12.1. So that's why we are running this command update source loopback 1. So source should be the IP address which is running on loopback 1 interface, right? After that, go to router 3. On router number 3 also, I'm going to configure BGP, router BGP 100 and neighbor 1.1.1 whose remote AS is 100 and neighbor 1.1.1 update source loopback 1. Done. Now BGP neighborship will come up between 1.1.1 and 3.3.3. Just wait. Yes, you can see the log message on router 3 who is neighbor 1.1.1 is up. Fine. So we have IBGP neighborship between 1.1.1 and 3.3.3. Now we are going to configure a BGP between PE to CE router. This is R1 is PE router, provider edge router. R3 is also provider edge router. And R2 is provider router, P router. So R2 is BGP free routers, right? On R2, I have not configured BGP. R2 is BGP free routers. Now let me configure BGP between router 1 and router 4 first. So on router 1, I'm going to say neighbor. IP address of neighbor is 14.1.1.4. This is IP address of router 4. And remote AS of this neighbor is 500. Remote AS of this neighbor is 500, right? Then go to R4. And on R4 also router BGP AS number 500 and say neighbor IP address 14.1.1.1 and remote AS of neighbor is 100. Soon BGP neighborship will come up between router 1 and router 4 also. Yes, you can see the log message, right? And now we are going to configure BGP between router 3 and router 5. So let me take you to R3 first, and here I am going to define one more neighbor command 35.1.1.5 which is IP address of router 5. Neighbor 35.1.1.5 whose remote AS is 500. And then go to R5. Here also let me enable BGP AS number 500 and say neighbor 35.1.1.3 remote AS is 100. Now soon BGP neighborship will come up between router 3 and router 5 also. Okay, you can see BGP neighborship. Guys, till here everything is clear? Everything is clear or not? Any question till here? This is basic configuration, right? Now I am going to advertise LAN interfaces in BGP. I am going to advertise 10 network on router number 4 and 50 network on router number 5. So let me take you to R4, and on R4, one second guys, one second. Yeah. So on R4, router BGP 500 and network 10.1.1.0 mask 255.255.255.0. And now, so IP BGP, you can check BGP table of router 4. Router have installed this prefix in their BGP table, and router 4 will advertise it with their neighbor. Who is neighbor? Router 1 is neighbor. So IP BGP summary. So 14.1.1.1 is neighbor. So router 4 will advertise it to R1. Let me check BGP table of R1 also. So IP BGP. So yes, inside the BGP table we are able to see 10 network. Correct. And next of IP address is 14.1.1.4. Now router 1 will advertise this network with their neighbor. So IP BGP summary, who is neighbor 3.3.3. So router 1 is going to advertise 10 network to 3.3.3 to this neighbor, right? So let me check R3 BGP table. So IP BGP. So inside the BGP table, we are able to see 10 prefix, but this prefix is only valid, not best. Now tell me the reason. Tell me the reason, guys. Why this prefix is not best, only valid? Hmm? Yes, yes. Because of next hop IP address. Next hop is 14.1.1.4. Router 1 have not updated next hop IP address because router 1 have share this prefix to their IBGP neighbor. So as you know, whenever BGP router will share prefix to their IBGP neighbor, router never update next hop address. But R1 is my edge router, so on my edge router I can run what command? Next hop self. So on R1 I am going to run next hop self command, router BGP 100 and neighbor 3.3.3 next hop self. Right. Now let me check again BGP table of router 3. So I need to clear BGP, clear IP BGP star soft in. And now if you will check BGP table here, you can see this prefix is now valid as well as best. Why? Because next hop is now 1.1.1.1 and 1.1.1 is reachable from router number 3. Correct, guys? Now router 3 will advertise this prefix to their neighbor. Who is their neighbor? So IP BGP summary. 35.1.1.5 means router 5. Router 3 is going to advertise 10 network to router 5. Let me show you BGP table of R5. So IP BGP. Here we are not able to see 10 prefix. Now tell me the reason. Router 3 have advertised 10 network to router 5. But here on router number 5 we are not able to see 10 prefixes in BGP table. Why? What is the reason? Correct. Because router 5 is receiving update with their own AS number. Right. So what I can do, I can tell to router 5, please allow AS, please allow AS in. You need to run this command. See, on R5, I am going to run this command, router BGP AS number 500 and the neighbor 35.1.1.3 allow AS in. Allow AS in. After running this command, if you will check BGP table again, so IP BGP, now we are able to see 10.1.1.0/24 and next hop IP address is 35.1.1.3 which is reachable from here. That's why this prefix is valid as well as best. Because router 3 have advertised this prefix to their eBGP neighbor. So router 3 have modified next hop IP address. Correct? So R5 means, let's say this is side 1. Yeah. Yes, they are on AS number. Let's say this is side 1 and this is side 2. Now side 1 prefixes are there in side 2. Inside the BGP table of R5 we are able to see this prefix, side 1 prefix, and so IP route BGP inside the routing table also we are able to see this prefix. Now I am going to advertise 50 prefix in BGP. So on R5 router BGP AS number 500 and say network 50.1.1.0 mask 255.255.255.0, and so IP BGP. You can see BGP table. It have installed this prefix also in their BGP table. Next up is 0.0.0 means it is self-advertised prefix, and now router 5 will advertise this 50 prefix to their neighbor to R3. So IP BGP summary to this neighbor 35.1.1.3. So let me check R3 BGP table now. So IP BGP, yes, R3 have received this prefix 50.1.1.0/24, and next of IP address is 35.1.1.5, which is reachable from router number 3. Now router 3 will advertise this network to their neighbor. So IP BGP summary, who is neighbor 1.1.1. So router 3 is going to advertise 50 prefix to 1.1.1. Let me check BGP table of R1. So IP BGP. Here we are able to see 50 prefix, but this prefix is again valid only, not best, because of next hop IP address. So on R3 also I am going to run this command router BGP 100 and say neighbor 1.1.1, say next hop self. Right now, if you will check BGP table of R1, clear IP BGP star soft in, and so IP BGP. Now we are able to see 50 prefix valid as well as best, right? And so IP route BGP. So router 1 have this prefix, side 2 prefix, and router 5 have side 1 prefix. So IP route BGP 10 prefix. Fine. Any question till here? This is also basic configuration. Here I have added one extra command, that is allow S in. Okay guys, clear? Now can 10.1.1.1 communicate with 50.1.1.1 or not? If I will ping from router 4 to router 5, this LAN user can communicate with each other or not? 50.1.1.1 and source is 10.1.1.1. Now ping is not working. Tell me the reason. Why ping is not working? Next hop? No. No. See, when I am pinging this IP address 50.1.1.1 from 10.1.1.1. So source IP is 10.1.1.1 and destination IP is 50.1.1.1. Now user will generate this packet, right, and user will forward that packet to R4, to their default gateway. R4 will check their routing table. R4 will compare destination IP address with their routing table. So IP route. Inside the routing table of R4, where is 50 network? So IP BGP. Here we need to, yes, on R4 router BGP 500 and neighbor for this neighbor 14.1.1.1 allow S in, and so IP BGP. Now 50 prefix is there, so IP route BGP, yes. And now let me check again connectivity 50.1.1.1 and source is 10.1.1.1. Still ping is not working. Why ping is not working? Correct. R2 routing table. Inside the routing table of R2, see what will happen when I will ping 50.1 from 10.1, right? Router 4 will compare their routing table. Router 4 will compare their routing table with the destination IP address. So IP route inside the routing table, yes, route is available. You can see for 50.1.1.0. Next hop is 14.1.1.1. That means router 1 will forward packet to router 4 will forward packet to router 1. Again, router 1 will compare destination IP address with next with routing table. So R1 is going to check the routing table. So IP route inside the routing table there is one route available for 50 network. So router 1 will forward this packet to 3.3.3. 3.3.3. Again, to forward packet to 3.3.3, router need what? Router 1 need exit interface. So router will look up their routing table again, and then router can see this entry. If I want to forward packet to 3.3.3, I will forward that packet from fast Ethernet 0/0. Next hop IP address is 12.1.1.2. Means router 1 will forward packet to router 2. When router 2 will receive packet, router 2 is again going to compare destination IP address with routing table. So IP route. But inside the routing table of router 2, we don't have 50 network. Right? So router 2 will discard the packet. Is it clear? Router 2 will discard the packet. So guys, what we will do here, we will configure MPLS inside the service provider. We will configure MPLS inside service provider, like on R1. For now, just I am going to run MPLS. We are not discussing how MPLS work and what is MPLS. Just I am going to enable it on router 1. I can run this command on fast Ethernet 0/0 IP. On fast Ethernet 0/0, I can run this command MPLS IP. This is command to enable MPLS on interface of router. This command will enable MPLS on fast Ethernet 0/0. In the same way, we will enable MPLS on router 2 also. 150 interface range fast Ethernet 0/0 and fast Ethernet 1/0 MPLS IP. Soon LDP neighborship will come up between router 1 and router 2. You can see LDP neighbor with 1.1.1 is up. Okay. Now on router number 3 also I am going to enable MPLS on fast Ethernet 0/0 interface fast Ethernet 0/0 MPLS IP. Okay, now we have LDP neighborship between router 2 and router 3 also. Now if I will ping, let me check connectivity again. Ping from router 4 to, yes, from this router I am going to ping 50.1.1.1 and source is 10.1.1.1. Now you can see ping is working. This is how two sides in real time, how we connect two sides together. Two sides together with service provider. Inside the service provider, guys, there will be multiple routers. As I told you in yesterday class also. Maybe here we have one router, here we have one router, here we have one router. All are directly connected with each other like this. This can be network of service provider, right? My requirement is there should be reachability between P to P. P to P. Fine. Only on WAN link. Only on WAN link. I have enabled MPLS on this interface, on this interface, on this interface, and on this interface only. Yeah, MPLS will be enabled on all routers inside the service provider. Okay. Now these router will forward packet on the basis of label. Earlier router 2 were checking what? Routing table, but now see router 2 will not check their routing table. Router 2 will forward packet on the basis of label. So MPLS forwarding table. You can see in forwarding table we have one label for 1.1.1 and 3.3.3. If router will 2 will receive a packet for 3.3.3, see local level and remote level. So on the basis of levels, you will understand this in MPLS course, right? How MPLS is working. Now these routers inside service provider are not checking their routing table to forward packet. Routers will forward packet on the basis of label. This is level. It can be random number, right? In MPLS series you will understand this, how router is going to assign label. See, when we enable MPLS on router number 1, what router 1 will do? Router 1 will assign one label for all the prefixes present in routing table. See, so MPLS forwarding table. Inside the forwarding table we are able to see one local level and one remote level. Local level is 16 and remote outgoing level is 17. Means router 2 have shared this level to router number 1 for this prefix for 3.3.3. All routers will assign one label to all prefixes present in routing table, and after that routers will exchange label with their neighbor, with their LDP neighbor. This is concept of MPLS, guys. I have a complete playlist on my YouTube channel for MPLS. You can learn MPLS from there. You can master in MPLS. Okay. So this is one scenario, real-time scenario, where we are using BGP. And this is how you will configure BGP in this scenario. On R4 and R5, you need to run allow AS in command, and inside the service provider, you will form indirectly connected IBGP neighborship. Any other question till here? Now router will not check routing table to forward packet inside service provider. Routers will check label to forward packet. See what is happening here. Pent. Let's say I have three router R1, R2, and R3. Here I have one LAN. R3, let's say here we have one LAN 10.1.1.0/24. Here I have one LAN 20.1.1.0/24, and here we will have one LAN that is 30.1.1.0/24. Let's say on these router I am running one IGP protocol, OSPF. We are running OSPF routing protocol on router 1, 2 and 3. So if I will talk about routing table of router 1, guys, inside the routing table of router 1, how many network will be there? 10, 10.1.1.0/24, then 20.1.1.0/24, then 30.1.1.0/24, then 12.1.1.0/24, and 23.1.1.0/24. When I will enable MPLS here on router number 1, router 1 will assign one label here, right? Let's say label for this prefix is 16, label for this prefix is 17 label for this prefix is, this is local label, is 18, label for this prefix is 19, and label for this network, this prefix is, let's say, 20, right? In the same way, router 2 will also assign label to all prefixes. Let's say this is routing table of router 2. Inside the routing table of router 2 also we will have these network 10.1.1.0/24, 20.1.1.0/24, and 30.1.1.0/24, right? And 12.1.1. Sorry, 12.1.1.0/24 and 23.1.1.0/24. Router 2 will also assign one label with all prefixes. Let's say router 2 have assigned label 50 for this prefix. For this prefix, router 2 have assigned label 51. For this prefix, router 2 have assigned label 52. For this prefix, router 2 have assigned label 53. For this prefix, router 2 have assigned label 54. Okay, in the same way, router 3 will also assign label for all prefixes. So this is, let's say, routing table of R3. Inside the routing table of R3, we will have 10.1.1.0/24, right? 20.1.1.0/24, 30.1.1.0/24, and 12.1.1.0/24, and 23.1.1.0/24. This router will also assign one label with all prefix. Let's say here this router have assigned this label 101. For this prefix, this router have assigned this label 102. For this prefix, router have assigned this label 103. And we can define label range also. Like here, I can tell to router 1, please start assigning label from 100 or from 200. Getting my point? Otherwise, router will start assigning label from 16, 17, 18, 19, like this. But if you will define a specific range of label, then router will assign label from that range only. Okay, so let's say here router 3 have assigned label 104 for this prefix, and for this prefix router have assigned label 105. And now these router are going to exchange this label with their neighbor. So here we have one neighborship, LDP neighbor between router 1 and router 2. Here we have one LDP neighbor between router 2 and router 3, right? Router 1 will share these label with router number 2. This label, this was local label on router number 1, and this label will become remote label for router number 2. Like this time, if router 2 need to forward a packet to 10.1.1.0/24, router will forward packet to router number 1 with what label? 16. With what label? 16. Okay, so router will not check routing table. Router will check MPLS forwarding table. Inside the MPLS forwarding table, you can see here, inside the MPLS forwarding table on router number 2, for 1.1.1, pop label means remove the label and forward packet from fast Ethernet 0/0. Next stop is 12.1.1.1. Inside the routing table of router 2, we don't have 10 prefix, 10.1.1.1. But router 2 can forward packet in 10 network to router number 1. Whenever router 2 need to forward packet in 10.1.1.0/24, router 2 will forward packet to 1.1.1. Okay. So MPLS forwarding table. This is forwarding table of router 1. And so MPLS okay, this is in MPLS, router will maintain two types of table. One is LIB table and another one is FIB table. LDP binding. So see, router one have assigned one label for all prefixes present in routing table, right? For 1.1.1 label is null. For directly connected prefix, for directly connected prefix, label will be null. For 23.1.1.2 label is what? 16. For 3.3.3 label is what? 16. For 12.1.1.1 label is null because 12 network is directly connected, right? So if you want to learn MPLS guys, you can start watching my video here. Let me show you. I have a complete playlist for MPLS. By watching this playlist, you can learn MPLS from basic to advanced. Internet. Playlist and all about MPLS. There are 38 videos in this playlist. Like why we need MPLS, how MPLS assign label to network, how label distribution protocol works, PHP concept, MPLS TTL behavior, IPv4 over MPLS, MPLS L2 VPN, MPLS L3 VPN with a static route, packet flow over MPLS L3 VPN, right? So you can start watching this video to learn MPLS. Here just I have enable MPLS only. I have not discussed how MPLS work. Is it clear? Yeah, yeah. Those videos. Just you need to pay 89 rupees. After that, you can download all videos in your computer. Correct? Or I can provide you one mail ID. Through that mail ID, you can log in to YouTube, and you don't need to buy subscription. So if anyone need, my mail ID, I can share with you. You can access all videos through that mail ID. Sure, I will provide you. Clear till here? Now, guys, in BGP, we have. Okay, try to understand one more scenario here of BGP. Let's say I have three router one, router two, and router three. R1, R2, and R3. Here I have one loopback 1.1.1. Here I have one loopback 32. Here I have one loopback 2.2.2. And here I have one loopback 3.3. Okay. So when I will configure BGP here, I need to configure rot reflector on router number 2, right? Let's say we are running BGP AS 100 on all routers. So I need to configure what? Route reflector. Otherwise, router 1 will advertise 1.1.1 to router 2, but router 2 will not advertise it to router number 3. So first option is we can configure route reflector. But see, if my topology is very large, I will show you the another topology. When topology will be large, then configuring route reflector is complicated. So what we can do in that scenario? I can form one BGP neighborship between router 1 and router 2. Here we will have one BGP neighborship, or we will have one BGP neighborship between router 1 and router 3. So router 1 will advertise this network to router 2 also to this neighbor, and to router number 3 also to this neighbor. Right. Because if you have, see, again here also we have problem. If we have 10 number of routers, then we need to configure lots of BGP neighborship, right? Let me open one topology here. I'm going to close this topology, guys. Okay? I'm going to delete it. Is it clear? Can you configure this scenario by yourself now? Vasavaraj, can you configure this scenario by yourself so that these two LAN users can communicate with each other? Okay, then let me move further. I think that topology is in EvenG. Let me open EvenG. What is happening? Now topic is neighbor peer group. Sometime you need to configure lots of BGP neighborship in large network. In that scenario, you can create one peer group. Like, see, here, if I want to form one BGP neighborship between router 1 and router 2 and one BGP neighborship between router 1 and router 3. So on router number 1, you will run how many command? Router BGP S number, let's say 100. After that, neighbor 2.2.2 remote S 100. After that, you will run neighbor 2.2.2.2 update source loop back 1. After that, neighbor, if you want to apply password, you will run this command neighbor 2.2.2 password, let's say Cisco 123. So for one neighbor you need to run 4 commands. So let's say we have 10 number of routers, so we need to run these 4 commands, these 4 commands for all neighbor. Means you need to run 40 commands on router number 1. You need to run 40 commands on router number 1. That's why we have a concept of neighbor peer group. I can run these all command in a group, and I can apply that those command with neighbor directly. Let me show you how. First of all, root and if. Let me access my to close. Yeah. BGP. Let's say this lab. Guys, see in this lab, if I want to for full mesh BGP neighbor, see like router neighborship between router 1 and router 3, neighborship between router 1 and router 2, neighborship between router 1 and router 4, neighborship between router 3 to router 5, router 4 to router 6. Like so, we need to run lots of command in this scenario. So we will not configure BGP like putting all command individually. Here I can create one peer group on router number 1. See how. First of all, let me close this unnecessary app. Let me check BGP is running or not. Here. Enable show IP protocol. So which protocol is running? Only OSPF. Okay. So through OSPF, so IP route OSPF. So IP route OSPF. So IP OSPF neighbor. Okay, just wait for some time. Neighbor is in two-way state. Yes. So IP route OSPF. You can see all loopbacks are reachable with each other through OSPF. That means we can form BGP neighborship. Correct, guys? So how many neighbor router 1 have? How many neighbor? Router 3, router 2 and router 4. For each neighbor I need to run how many command? 4. Right? That means I need to run 12 number of command on router number 1. But if I will create one peer group on router number 1, we can reduce lots of command here. On router number 1, I can run this command. Config t router BGP AS number 100, router BGP AS number 100, and then neighbor, and give one name of peer group. Let's say IBGP. I have defined this name, right? And then peer group. Peer group. Now my peer group name is IBGP. And now whatever command I want to apply, I will run for this IBGP peer group. Like neighbor IBGP, and then I can say what? Update source, update IBGP, update source, loopback 1. Update source loopback 1 do so IP interface brief exclude unassign. Let me check this loopback 1.1.1 is running on which loopback interface? On loopback 1, on loopback 10. So command should be this one. Let me remove this command. And here I am going to say neighbor I BGP update source loopback 10. After that, neighbor I BGP and remote S is 100. Then neighbor IBGP password, let's say Cisco 123. No, I am just creating one group. Whatever command I have defined in this group in IBGP, I will apply IBGP with neighbor. Automatically all command will apply for that neighbor. Neighbor IBGP password Cisco 123 remote yes this one update source loopback 1, all command will apply directly for neighbor. Getting my point? Like on this router, now I can say neighbor 2.2.2.2 means router 2. I want to for BGP neighborship between router 1 and router 2, so I can run this command neighbor 2.2.2 and peer group IBGP. Name of peer group is IBGP. Automatically for this neighbor all command will apply. Whatever command I have defined in this group. Getting my point? Right? For neighbor 3.3.3, again I am going to call peer group IBGP. For this neighbor also IBGP. For 3.3.3 I have, let me remove this command and say neighbor to saying neighbor 3.3.3 peer group IBGP. Sorry, IBGP. Right now, all command is applied for this neighbor also. I will do same thing for 4.4.4 also. For 4.4.4. There is some misconfiguration. Let me say no router BGP yes number 100. Router BGP, let me configure again guys. BGP 100 neighbor IBGP peer group. Then neighbor IBGP update source loopback 10 neighbor IBGP remote S 100 okay, and neighbor IBGP password Cisco 123, and neighbor I am going to apply these all command with neighbor 2.2.2 peer group IBGP. For neighbor 3.3.3 also, for 4.4.4 also. No MD5 dash. Okay, authentication is mismatching. 4.4.4 for 4. Neighbor 4.4.4 IBGP peer group. Peer group IBGP. Done. Then go to router 2. On router 2 also I can create one peer group, and I will apply that peer group with all neighbor. So let me configure here router BGP case number 100 and neighbor IBGP. Name can be different or it can be same also. Peer group neighbor IBGP update source loopback 1 neighbor IBGP remote AS 100 and neighbor IBGP password Cisco 12 do so yes interface brief exclude and assign loopback 10. So let me remove this command and say neighbor IBGP update source loopback 10. And now I am going to apply it with neighbor. Say neighbor 1.1.1 neighbor 1.1.1 and peer group IBGP. Soon BGP neighborship will come up between daughter 1 and daughter 2. After that I will apply same thing for 3.3.3 also. You can see the log message for 3.3.3 and for 4.4.4 also. 4. Right? Now let me take you to R3. Router BGP S number 100 neighbor IBGP peer group and then neighbor IBGP update source loopback. Let me check loopback interface here also. Do so IP interface brief exclude unassign loopback 10. So neighbor IBGP update source loopback 1 loopback 10 neighbor IBGP remote AS 100 neighbor IBGP password Cisco 123. And now I am going to call this peer group with neighbor 1.1.1 peer group IBGP neighbor 2.2.2 peer group IBGP neighbor 3.3.3 peer group IBGP. Done. Soon BGP neighborship will come up. Yes, you can see neighborship with 2.2.2 and with 1.1.1. Now let me configure R4. So like this also you can configure BGP by creating one peer group. If you have lots of neighborship. Router BGP AS number 100 neighbor IBGP peer group then neighbor IBGP update source loopback 10 neighbor IBGP remote AS 100 and neighbor IBGP password Cisco 123. And then finally let me call this peer group with all neighbor 1.1.1 peer group IBGP. Same thing for 2.2.2 also. and for 4.4.4 also. Sorry, 3.3.3.4. And now on any router you can verify BGP neighborship. So IP BGP summary. 1.1.1 is neighbor, 2.2.2 is neighbor, and 3.3.3 is neighbor. 3.3.3 password is mismatching. No MD5 digest for 3.3.3 to 4.4.4. So run section BGP. So it is correct. Here I have not defined neighbor 4.4.4. So router BGP 100 neighbor 4.4.4 peer group IBGP. Automatically all command will apply for this neighbor. Update source loopback 1, password or remote yes. Now we are expecting BGP neighborship between router 3 and router 4 also. Yes, you can see neighbor is up. So on router 4 BGP summary you can see. Router 1 is neighbor, 2 is neighbor and 3 is neighbor. Correct guys? So you can configure BGP like this also. Can I move? Any question? Now, if I will advertise this network, TAM network in BGP, or one more thing here, on router number 1, let's say I want to advertise only this network, 10.1.1.0/24 only in BGP, or whatever IP address is running on loopback 1 interface, I want to advertise that only in BGP. So that also I can do by creating one route map, like on router number 1. If I want to advertise, do show IP interface brief exclude unassign. See, I want to advertise, let's say, only this network in BGP. Only this network in BGP. So what I can do, I can create one route map here, and name of route map is, let's say, loopback 1. Permit. And here what I will say, match interface loopback 1. And after that go to router BGP 100, and here I can say redistribute connected, use route map. If I will not use route map, it will redistribute all connected prefix. So if I will use route map, here name of route map is loopback 1. Loopback 1. That's it. And now if you will check BGP table, so IP BGP, you can see inside the BGP table we have only this network. So like this also you can advertise prefixes in BGP. And now router 1 will share this prefix to their neighbor, to router 3, to router 1 and to router 4. So on all routers you can verify, like on router number 2, so IP BGP. Correct guys? Now concern is, on router number 2 we are able to see 10 prefix, and next hop is 1.1.1. R3 will also advertise this network to router number 2, R4 will also advertise this network to router number 2, and R1 will also advertise this network to router number 2. Now, how router 1 is performing best path selection? How router is performing best path selection? Because on router number 2, we are able to see this network is reachable via router number 2. If this interface, let's say config T, interface fast Ethernet 1 slash 0 will goes down, let's say shut down. And now, so IP BGP. Now, still we are learning this prefix. Still, we are learning this prefix. Next of IP address is 1.1.1. Next of IP address is 1.1.1. So this time, R2 is learning 10.1.1.1 from their other neighbor, like from maybe router 3 or from router number 4. So to understand this, how router 2 is learning 10 prefixes, or how router 3, 4, any other routers learning prefixes or selecting best path, you have to understand BGP attribute. BGP attribute. So my next topic is BGP attribute. So guys, please let me know any question till here. Best path selection in BGP. Now we are going to understand best path selection in BGP. So IP route OSPF. See, 1.1.1 is reachable through router 4 also and from router number 3 also. IGP cost is 3 from both sides. So router 2 is performing what? Load balancing for 1.1.1. Right? And so IP route BGP. BGP. See, 10 network is here with reachable via 1.1.1 and 1.1.1 is reachable via router 3 and router 4 because fast Ethernet 1 slash 0 of router 2 is down. So router 2 is not performing load balancing for this network. Router 2 is performing load balancing for this network 1.1.1 because router 2 is learning 1.1.1 from router 3 and router 4 with same cost. Again, I am going to up this interface. Interface fast Ethernet 1 slash 0, say no set. So IP route. Now you can see 1.1.1 is reachable again via 2 path. Just wait. Yes. Now you can see 1.1.1 is directly reachable. 1.1.1 is directly reachable via 12.1.1.1 means via router number 1. So this time, if router 2 need to forward packet in 10.1.1.0/24 network, it will forward packet to router 1. Earlier, if this link is not working, link between router 1 and router 2 is not working, then definitely router 2 will forward via router 3 or via router 4. That means router 2 is receiving 10.1.1.0/24 network from their 3 neighbor, from all neighbor, from router 1 also, router 3 also, and from router 4 also. But it have installed via router number 1, right? So this is what best path selection. So try to understand best path selection in case of BGP, guys. We have some attributes. Let's say I have a topology like this. Router 1, router 2, and router 3. R1, R2, R3. Here we have one network, let's say 10.1.1.0/24, and here also we have one network 10.1.1.0/24, same network. Between router 1 and router 2, we are running BGP. Between router 1 and router 3 also we are running BGP. So both neighbor, means router 2 and router 3, both will advertise same network to router number 1. And how router 1 will perform best path selection. How router will perform best path selection. See, router 2 will also advertise this network to router 1 and router 3 will also advertise this network to router 1. Right? So router 1 will check path attributes for best path selection. Then router 1 will decide I will install this prefix via which router? Via router 2 or via router 3. Okay, guys. So see how many attributes we have in BGP. First attribute is next hop. Let me write here. And router is going to check attribute in same sequence. Like here I am mentioning attribute. First attribute is next hop. Next hop. What do you mean by next hop? Means next hop IP address should be reachable. First, let me write down all attributes, then we will discuss all one by one. Second attribute is wait. And wait is Cisco proprietary attribute. Right? Only on Cisco devices you will see this attribute, wait attribute. After that, third attribute is local preference. Fourth attribute is ES path. Fifth attribute is origin code. Then router will check sixth attribute, that is MAT. MAT means metric. MAT is sixth attribute. Next hop, wait, local preference and self-advertise here. After local preference, we will have this attribute, self-advertise prefix. Self-advertise. ES path is fifth attribute. This one is fifth attribute. This one is sixth attribute, and this one is seventh attribute. And then eighth one is what is happening? Eighth one is external over internal. External prefix will be always prefer over internal. So external over internal. Then IGP cost to reach next hop. IGP cost to reach next hop. Then oldest path first. Oldest path. But this attribute will work in case of eBGP only. In case of eBGP, not in case of iBGP, oldest path. And 11th attribute is lower neighbor router ID. And 12th attribute is lower neighbor IP address. So BGP router is going to check these all attributes for best path selection. Okay. First of all, router will check next hop IP address. Next hop should be reachable. Let's say here we have one IP address 12.1. Here IP address is 12.2. Here IP address is 13.1. Here IP address is 13.2. So let's say both routers are advertising this prefix 10.1.1.0/24 to router number 1. Right, and this next hop is not reachable from router number 1, then definitely router 1 will install this prefix via router number 2. But in this scenario, both next hop address is reachable from router number 1. Yes or no? Both next hop is reachable from router number 1. That means this attribute is tie here. Then router 1 is going to check wait attribute. And as I told you, wait is an Cisco, or let me design another topology here for attributes. Guys, please write down these all attribute in your notebook somewhere, because this is very important. This is very important. Okay. See, let's say I have this topology R1, R2, R3, and R4. And R4 is connected with one LAN, let's say here. R1, ten dot one dot one dot zero slash 24. 10.1.0 slash 24. Okay, now here IP address is, let's say, 12.1. Here IP address is 12.2. Here IP address is 13.1. Here IP address is 13.3. Here IP address is 24.2. Here IP address is 24.4. Here IP address is 34.3. And here IP address is 34.4. And we are running, let's say, BGP AS number 100. Now tell me, when router 4 will advertise this network to their neighbor, means to router number 2 and router number 3, what will be next hop IP address? When router 4 will advertise this prefix to router number 2, what will be next hop IP address? 24.4. Right. So this will be next hop IP address. And when R4 will advertise this prefix to router number 3, then this IP address will be next hop. When R2 will advertise this network to R1, will R2 modify next hop address? Will R2 modify next hop address, guys? No. In the same way, when R3 will advertise, R3 will also not modify next hop address. Means next hop address is not reachable from router number 1. So router 1 is first attribute is what? Next hop. Next hop should be reachable. Next hop should be reachable. So let's say I want to use this path. I want to use this path. Here I can tell to router 2, please modify next hop address. I can use route map. If this router is border router, then I can run next hop self command. Right? If I want to use this path, so on router number 3, I will modify next hop address only. Getting my point? But let's say both next hop is reachable from router number 1. We are running one IGP protocol. Then next hop attribute is tie. Then router is going to check next attribute, wait attribute. And wait is Cisco proprietary attribute. BGP not carry wait information in the update. BGP never carry wait information in the update. It is locally significant. For self-advertised prefix, wait will be always 32768. 32768. For self-advertised prefix, wait will be this one every time. Okay. For receive prefix, wait will be always what? 0. So here also wait is 0. Here also wait is 0 because both are received prefix, not self-advertised prefix. So wait attribute is also going to be tie here. Yes or no? On here on in this topology, R1, so IP BGP. For self-advertised prefix, wait value is what? 32768. And on router number 2, if you will check BGP table, so IP BGP. What is wait? 0. Why? Because this is received prefix. So always keep in mind, wait is a Cisco proprietary attribute, and BGP update message never carry wait information. For received prefix, wait value will be always 0, and for self-advertised prefix, wait value will be always 32768. And higher bit wait value is always preferred. Higher wait value is always preferred. But I can configure wait value like by default both router are advertising 10 prefixes to router number 1 with wait value what? 0. But if I want to use upper path, so here I can set wait value, let's say 5. So now router 1 will select this path, upper path, as a best path. Because from router number 2, router is getting this prefix with wait value 5, and from router number 3, the router is getting with wait value 0. And higher wait value is always preferred. Okay, but by default, again in this scenario, wait value is 0 from both sides. So this attribute is also tie. This attribute is also stub. Next hop, yes. How? Please again. Because both next hop is reachable. Here I have set this IP address as a next hop. Here I have set this IP address as a next hop. So both next hop address is reachable from router number 1. Both next hop address is reachable from router number 1. Then router will check next attribute, that is wait. So wait value is also 0 from both sides. Then router is going to check next attribute, that is local preference. Like in this scenario, router 1 is advertising one network, 10.1.1.0/24. So router 1 is advertising it to router 3, router 4, and router 2. Will router 4 advertise that prefix to router number 3? Answer is no, because of IBGP loop avoidance mechanism. But let's say here I have configured route reflector. So router 4 is also advertising this prefix to router number 3. So when router 4 will advertise this network to router number 3, router 4 will not modify next hop address. So next hop IP address will be the IP address of this interface. Right? And if this interface IP address is not reachable from router number 3, then router 3 will perform best path selection on the basis of what? Next hop attribute. Because one next hop is reachable, one next hop is not reachable. Getting my point? Let's say in this scenario, here we are running BGP AS number 100 on router number 1, 2 and 3, and on router number 4 we are running BGP AS number 200. BGP AS number 200. So now router 2 and router 3 is what? Border router. If I want to use upper path, so on router number 2 I will use next hop self command. If I want to use lower path, I will run next hop self command on R3. Getting my point? So with the help of wait attribute, I can manipulate the path. Okay, and in upcoming days we will see how to configure wait value also, how to configure local preference, right? I will show you practically also, guys, these all things. I will show you practically also. Like in this scenario, see one thing. This is my scenario, right? In this scenario, on router number 2, we are able to see 10.1.1 is reachable from router number 1. First, router 2 will check what next hop. Next hop is reachable from all side. From router number 3 also, from router number 2 also, from router number 1, from router number 3, and from router number 4. Weight value is, next hop is reachable. Then router 2 is going to check weight value. So weight value from all side is 0. But if I will configure weight 5 from router number 3, then router will install this prefix via router number 3, not via router number 1. Okay. After that, if weight value is also same tie, then router is going to check local preference value, third attribute. And always keep in mind, BGP will always carry local preference information in its outgoing update, but only for IBGP neighbor, not for EBGP neighbor. Not for EBGP neighbor, only for IBGP neighbor, router will carry local preference information inside the update message. And by default, local preference value is 100 in outgoing update, and higher value is always preferred. So in this scenario, weight value is going to be what? Local preference value is going to be what? From this side and from this side. From both sides, local preference value is going to be 100. Okay, because router 2, router 3, both router are advertising prefixes to their IBGP neighbor, right? And in this scenario also, router 1 is advertising 10.1.1.0/24 to their neighbor, to their IBGP neighbor. So because of that, on R2 we are able to see local preference value what? 100. Local preference value 100. Clear? So if local preference attribute will tie, then router is going to check next attribute, that is self-advertise. Self-advertise means what? If router 1 is advertising this network, same network 10.1.1.0/24, so self-advertise prefix will be always preferred on receive prefix. Self-advertise prefix is always preferred on receive prefix. Okay. So, but in this scenario, router 1 is not advertising 10.1.10.0/24. Router 1 is receiving from two neighbor, right, with same local preference value, and here self-advertise attribute is not going to be work. Router will check next attribute, that is AS path. That is okay. Self-advertise means, let's say I have two router, R1 and R2. R1, R2. R1 is connected with one network. 10.1.1.0/24, let's say, right? And router 2 is also advertising same network to router number 1. Same network, router 2 is also advertising 10.1.1.0/24. So this time router 1 will compare. I am advertising same network and I am receiving also same network from neighbor. So router 1 will prefer self-advertise prefix here. Router 1 will not install receive prefix. Reason is what, guys? For receive prefix, weight value will be what? 32768, and for self-advertised prefix, for self-advertised prefix, weight value will be 32768, and for receive prefix, weight value will be what? 0. So which one is best? Self-advertised. Okay. After, is it clear? Dana? No, no. For summary route is again different. Na then that is different network. If router 2 is advertising, let's say this network 10 dot 0 dot 0 dot 0, definitely router 1 will make one entry in their routing table for this network also, because this network can on R1 we will perform summarization. Yes, those come under self advertise. That also come under self advertise. After Mhm. Correct. After that, next attribute is AS path. If till here router have not decided which path is best for me, then router is going to check what AS path. AS path means, let's say on router number 1 we are running BGP number 100. On router number 2 we are running BGP number 200. On router number 3 we are running BGP number again 100, and on router number 4 we are running BGP number 400. So when router 4 will advertise this 10 prefixes to router number 2, it will add AS number or not? No. Yes or no? Because it is advertising to their IBGP neighbor. So it will not include AS number. But when router 2 will advertise it to router number 1, it will add AS number 200 here. When router 2 will advertise this prefix to router number 3, it will add AS number 200. And when router 3 will advertise same prefix to router number 1, it will not add AS number. Let's say here AS number is 300. Then router 3 will add AS number, there on AS number 300 and 200. So this time router 1 is receiving same prefixes from two neighbor, and router 1 is receiving prefixes from one neighbor with one AS number and from another neighbor with two AS number. And lower is always preferred. Lower value is always preferred. So you tell me which path is best according to AS path. Upper path or lower path? Upper path is the best path. So in this scenario, on the basis of AS path, router 1 will perform best path selection via router number 2. Okay. Lower value is always preferred. But in this scenario, let's say we are running a same AS number, here AS number 100, here AS number 200, right? Then router is receiving prefixes from both neighbor with same number of AS path. Then router will check next attribute, that is origin code. And there are, guys, three types of origin code. One is I, E, and question mark. Incomplete. I means IGP. This is for BGP. When we are advertising a prefix with network command, then origin code will be I. See here, on router number 1, I have advertised 10.1.1.0/24 on router number 1 with redistributed command, not with network command. On router number 1, so IP BGP. So here you can see origin code is incomplete. Origin code will be incomplete for redistributed prefix, right? So if we are advertising a prefix with redistribution method, then origin code will be question mark. If we are advertising a network with network command, like on router number 1, if I will remove redistribution command here, so run section BGP. I'm going to remove redistribution command config T router BGP case number 100, and I'm going to remove this command. no redistribute connected route map loop back 1 and show IP BGP. Router BGP is number 100, no redistribute connected. So IP BGP. Now we don't have any prefix in BGP table. Now I am going to advertise one network through network command. Router BGP is number 100 and say network 10.1.1.0 mask 255.255.255.0 and now check BGP table. So IP BGP. Origin code is what? I. So whenever we will advertise prefixes with the help of network command, origin code will be I. Whenever we will redistribute prefixes in BGP, origin code will be question mark. And this E origin code is not in use nowadays. This is for EGP. Earlier we had one protocol called EGP. So this E symbol is for that. Nowadays this is not in use. Okay, and always keep in mind I is prefer than question mark. Means if you are advertising a network with network command and you are advertising same network with redistributed command, then which one is preferred? I origin code will be preferred there. Okay. For both IBGP and EBGP. For both. When I will advertise network with the help of network command, then origin code will be I. And whenever we will advertise prefixes with the help of redistribution, then origin code will be question mark. That is incomplete. And I is always preferred over question mark. So in this scenario, in my scenario, I have, let's say, advertise this network with the help of network command. So router 4 will advertise this network with origin code I, and router 4 will advertise this network to router number 3 with origin code I, and same thing will be happen here also. Router 2 and router 3 will advertise it with I. So again, this attribute is tie. Then router will check what? Metric. Multi-exit. Yes. Where is IGP? BGP. This is BGP. Okay. So now router is going to check next attribute, that is MAD. MAD means metric. It is metric, like metric in OSPF or metric in AGRP in any routing protocol. Let's say here we are running EIGRP protocol. EIGRP. Here we are running what? BGP protocol. So definitely router 2 and router 3 will calculate one metric for this network, right, in EIGRP. And when router 2 and router 3 will advertise EIGRP prefix in BGP, EIGRP prefix in BGP, it will add metric. Let's say here metric is 10, here metric is 20. So lower value is always preferred. Lower value is always preferred. Clear? Let's say I have a topology like this. R1 connected with R2 and R3. Here I have one network 10.1.1.0/24. Here also I have one network 10.1.1.0/24. And router 2 is learning this network through, let's say, EIGRP. And metric AD value will be 90 and metric is, let's say, 100 here. And From on router number 3, AD value is 90 and metric is let's say 150. 150. So when router 2 and router 3 will advertise this prefix in BGP, it will add this metric. So router 1 will get 10.1.1.0/24 network from router number 2 with what metric? 100, and same network from router 3 also with what metric? 150. So which one is best? Via router number 2. Lower is always best. If this attribute will also tie, metric is also same, then BGP will check next attribute, that is external over internal. External over internal. Here you can see we are running BGP 200. Here we are running let's say BGP 100. So both router is advertising same prefix 10.1.1.0/24. For router 1, which path is best? For router 1, which path is best? Till med, let's say all attributes are same. Then router will check external over internal. I am receiving same prefix from external neighbor also and from internal neighbor also. So external is going to be preferred over internal, because for external AD value is 20, for internal AD value is 200. Done. But let's say both are IBGP neighbor or eBGP neighbor. Then this attribute will also tie. Then router will check next attribute, which is IGP cost to reach next hop. IGP cost to reach next hop. Let's say here we are running what? OSPF protocol. So router 1 is getting this prefix from this side and from this side. Let's say here next hop address is 34.4. Here next hop address is 24.4. So router 1 will check IGP cost to reach next hop. IGP cost to reach next hop, and lower value is always preferred. Let's say OSPF cost to reach 24.4 is 1 and OSPF cost to reach 34.4 is 2. So which one is best? Upper path is best. According to IGP cost to reach next hop, router 1 can perform best path selection. But again, let's say IGP cost to reach next hop is also same. IGP cost to reach next hop is also same. Then router will check next attribute. Next attribute is oldest path. Oldest path. But oldest path is for eBGP neighborship. For eBGP neighborship. Let's say both are eBGP neighbor. Router 2 have also advertised this prefix and router 3 have also advertised this prefix to router number 1. Both are eBGP neighbor. Then router will check which path is oldest. Which path is oldest path. Like your old friend is best friend. So router will check first I have received this network from which neighbor, from router 2 or from router number 3. Let's say router 1 have received this network first from router number 2. So router will install this prefix via router number 2. But this will happen only in case of eBGP. Again, this attribute will not work. Then router will check next attribute. Next attribute is lower neighbor router ID. Let's say both are IBGP neighbor. Here this is AS number 200. Then router will check what? Lower router ID. Router ID of this router is let's say 2.2.2.2. Router ID of this router is 3.3.3.3. So lower neighbor router ID. Router 2 have lower neighbor router ID. So router 2 will install this prefix via router number 2. And let's say here we have two link. Here we have two link. We have two BGP neighborship between router 1 and router 2. Then router ID will also type. Then router 1 will check what? Lower neighbor IP address. Here IP address is, let's say, 12.2. Here IP address is 30.1. So lower neighbor IP address. This one is lower IP address. So this path will become best path. Okay, guys. So router ID will be always unique, right? On the basis of that, definitely router will select best path. And if router ID will also type, then neighbor IP address can't be same. Neighbor IP address can't be same. Neighbor IP address will be always different. And tomorrow we will see these all attributes practically. These all attribute practically. Okay. So these are, guys, attribute. You can take one screenshot of it also if you want. And in this sequence, router will check attribute. Router will check attributes. Okay, is it clear? Okay. Don't worry, in practical you will get. In practical you will get, because we will perform multiple practical with all attributes. We will configure wet attribute. Again, we will discuss these all attribute practically when I will perform practical in this topology. In this topology, see, all routers have multiple neighbor and receiving prefixes from multiple neighbor. So how these routers are performing best path selection, we will see that. Yeah, now you guys need to install EvenG. So what I am going to do here, I am going to send you one video. Through that video you can set up EvenG in your laptop. And if you will have any issue, then definitely I will help you. EvenG PM networking. This video. Inside the description you have link to download images, right? I am sharing this video with you guys.